about capacitors. So we reached the point where we want to talk about combination of capacitors. So we said that capacitors are electronic devices or components. We can use them in circuits. And there are two ways to connect, or actually three ways to connect a certain device. Let me actually open a white screen first, and then I will move to the specifics. Okay, so if we have two components of the circuit, في يكونوا batteries, في يكونوا capacitors, later on we're going to see we're going to have resistors. I can connect them in either way. The first way to connect things is I connect them from one terminal. So remember, each electronic component has two terminals. So if this is the component A, it would have a terminal A1 so it would have two sides if you want. So let's draw it here. So any component, let's make it larger. Let's call this A, component A. It would have two terminals, like the battery. It has positive and negative. The capacitor and one plate and the other plate. The resistor is going to have two sides as well. So where do I have a star? I cannot see the star. There's the star. No, okay. So it has terminal A1, where I can connect it to the outside if you want, and terminal A2, where I can connect it to the outside as well. Okay, so I can call those A1 and A2. Now, when a circuit, I want to connect things in a circuit. If I take two devices, two components, A and B, so let's call this A and B. The first thing I can do is I can connect them from the terminal A2 to B1. So I can connect them from here. Then I have nothing else in between them. So there is no branching in between them. So the charge that leave A2 has only to go to B2. So the connection between them is a straight connecting wire. And other sides could be connected to the other parts of the circuit. So I can connect this to this here and this to something else. I don't care what they are connected for. Now, when we have this connection, this connection from shape fill, no fill. Okay, it means that A1, sorry, A2, let's label them terminal A2 and B1, 1 or 2, it doesn't matter which one I call it. So B1, they are at the same voltage. They are connected by a connecting wire, and the charge that leave A2 has to go to B1. So let's write this down. The terminal A2 is connected to terminal A1, B1 with a perfect conductor and there is no branch in between. يعني that means any charge leaving A2 can only go to B1 and vice versa of course. بس طبعا التشارج positive or negative يعني اذا كنا عم بيطلع negative charge من ال A2 بيصير ال B1 negative وال A2 positive and vice versa. Later on we're going to see that that applies also for current because current is the flow of charge, but we didn't define current yet. So this is called a series connection. So A and B are connected in series. So this is, I call it a series connection. I could have a different kind of connection. The other connection is I kind of keep the connection between A and B, but I'm going to do it from the other side. So this is A2, this is B1 here now will B2 صارت لهي الميل اللي حطها هوصلهم من الميلتين. So I'm going to connect them from both sides. So I'm going to connect A1 to B1 and I'm going to connect A2 to B2. But of course, if I do this connection, this doesn't make any sense unless I make branches. So I'm going to allow branching on both ends. Oops. Copy paste that one. So I'm going to allow charge to go somewhere else as well. So in this connection, we have the terminal A1 connected to A2. So A1 connected. So now I'm going to just make it short. So when I say connected by a perfect conductor, يعني, connected to B1 and A2 connected to B2. يعني voltage, let's open an equation. Voltage at A1 is equal to the voltage at B1 because there's a wire between them. And the voltage at A2 is equal to the voltage at B2. So it means that we don't care about the absolute voltage, we care about the difference in voltage. So delta V, the voltage difference between the terminals across A is equal to delta VB. The voltage difference across A is equal to the voltage difference across B. هلا بالسيريز ال A2 وال B1 are at the same voltage, but the difference across يعني من ال A1 لل A2 مش ضروري يكون مثل ال B1 لل B2. But here we have to have this connection. Now, but there is branches at both sides. يعني التشارج اللي بيطلع من ال A1 مش ضروري كله يروح على ال B1 ليه؟ لأنه عنده external term they can go at. So we have these branches here. So these branches allow to the flow of charge to come from outside or go outside. So there is branches at both sides. It meaning that the charge leaving A1 can go somewhere else than B2, and the same on the other side. Same on the other side. This is called parallel connection. So A and B are connected in parallel. So the condition to have series connection is to have this connection between the two terminals with no branch. The condition to have parallel connection is to have the connection from the both terminals, but we could have branching, but we have to have this direct connection. We cannot have a difference in voltage between A1 and B1 or between A2 and B2. Now, we could have something other than that. So there might be another device in the middle, and I could have this connection here. But I have something else here. So I could have another device here. Let's copy this and call it C. Okay, so we look from A1 to B1. A1 is connected to B1, but there is a branch. Now A2 is not connected to B2. ليه؟ لأنه في C2 in the middle. So the voltage is not the same. It's not necessarily the same voltage because we have to take into consideration the voltage across C. So in this combination, it's neither series or parallel. So this A1 connected to B1, but there is a branch, and A2 is not directly connected. So again, when I say connected or directly connected, I mean with a perfect conductor, because otherwise I always have connection. I have to have a closed circuit, so charge has to be closed everywhere. But in order to have this parallel connection, I need to insist that my voltages are equal. It means that I have to have a perfect conductor connection. So here we have A1 connected to A2, but there is a branch. So التشارج اللي بيطلع من A1 مش ضروري يروح على A2 على B1. And A2 is not directly connected to B2. So this connection is neither series nor parallel. Okay, so I have a combined connection. Now we see how we resolve these connections. Right. What does it mean exactly for capacitors when they are connected in series or in parallel? So if we take two or more capacitors and we connect them in series directly by a connecting wire. So we have C1 connected in series to C2 and C2 connected in series to C3. You see this no branches in between thing. Then we take the whole combination and connect it across a battery, like here. Now, the voltage P is going to be the same as the terminal of the first capacitor. Then here the voltage is going to be the same as here. Then the voltage here is going to be the same as here because they are connected in contact. And then the last capacitor is going to be the same as the battery. Now, for the C1 to have voltage and C2 to have voltage and C3 to have voltage, we need to have separation of charge. So there should be some electrons moving from the first plate of C1 going to the positive plate of the capacitor. And the electrons going from the negative plate of the battery or terminal of the battery to the second plate of the third capacitor. In between, in the middle, the charge that leave this plate or the electron, the charge that leave this plate can only go to this plate. يعني إذا في شيء هيدي بدها تصير negatively charged، إذا بده يجي عليها 100 إلكترون، هال 100 إلكترون من وين بده يجوا؟ بده يجوا من هيدا البليت. So I could only have minus Q here and plus Q here. So the charge have to be the same. So the accumulated charge on C1 and C2 and C3 have to be the same. It's equal to Q because they are connected in series. So charge has nowhere else to go. But يروح من one capacitor للثاني ومن الثاني للثالث and then of course it depends on how many I have in my circuit. But the voltage difference is not the same. The voltage actually of the battery is divided across the capacitor. So the voltage here is the same as here. The voltage here is the same as here. But in between, it's divided. So the voltage delta VPN in magnitude is equal to delta V1 plus delta V2 plus delta V3. So the battery is providing the voltage that causes this charge separation on all the capacitors. So the voltage of the battery is divided across the capacitors. Now, of course, I still know that the charge and the voltage across each capacitor are related by its capacitance. So حسب الكاباسيتنس تبع الكاباستر في relation بين الفولتج والcharge. We know that Q is equal to C delta V for each capacitor. And of course, if we're talking about magnitude, we should at least put absolute value for delta V. So we have delta V is equal to Q over C. So I have Q1 over C1 instead of delta V1, Q2 over C2 instead of delta V2, and Q3 over C3 instead of delta V3. Now I can ask the question, what if I remove all this combination and put one capacitor to replace them all, an equivalent capacitor that would replace all three capacitors? Now, this capacitor should have the same charge. لأنه هون minus والplus they cancel out. Minus والplus they cancel out. So it only has plus Q and minus Q at the end. So it would have a charge Q. And it should have the same voltage as the battery. So this should be equal, Q is equal to C equivalent delta VPN. So now I can replace that back in this equation. And I found that 1 over C equivalent is equal to 1 over C1 plus 1 over C2 plus 1 over C3. It means that the capacitor that replaces all three capacitors that we place in series is actually smaller than all of them. Why? Because we're adding the inverse. So this equation gives us 1 over C equivalent. Then we have to flip it to find C equivalent. So C equivalent actually is less than the smallest of all the capacitors. And that makes sense because if you see, like, what we're doing is we kind of increasing the distance between the plates. So as if we have one capacitor that has the combined distance between the plates of the three capacitors. Okay, now let's put them in parallel. If we put them parallel, now connect them all this and we have the branch in between. And here we also have the branch. Now we connect the branch to the positive pole of the battery and the other branch to the negative pole of the battery. Now C1, C2, C3. Now this is going to be positive. This is going to be positive. This is going to be positive. Why? Because all of them are going to have the same voltage as the VP. The other side, this is going to be negative. This is going to be negative. And this is going to be negative. So they are not enforced by charge. So that you see the positive, all the positive are on the same side. So when we want to replace them by a new capacitor, this capacitor going to have the sum of the charges. And on the other side, we're going to have the sum of the negative charges. So the equivalent capacitor is going to have a charge Q that is equal to Q1 plus Q2 plus Q3. And because they are all connected to the batteries, to the battery, delta VPN is equal to delta V1 equal to delta V2 equal to delta V3. So Q1 over C1 is equal to Q2 over C2 equal to Q3 over C3. Now, the equivalent capacitor should give me the total charge under the same voltage. So when we replace Q1 by C delta V1 and C by delta V2, we cancel out delta V and we get the equivalent capacitor is the sum of all three of them. Okay. So let's solve some problems about that. Let me open the book and open the file that we used to write the problems. So we keep them all in one file. I'm trying to remember which page we were on. I think 380 or something like that. 370 something. So let's look at problem 68 in the book. Let me copy it and I will share the PowerPoint with you easier. So page 375. For the capacitor network shown in the figure, find the equivalent capacitor, find the charge on each capacitor when the entire combination is connected to a 6-volt battery. So now, let's label our capacitors. So I will label this C1. هيك حتى نعرف to refer to them. And this is C2. And C3 and C4. So let's call this C4. I can see it more. And then C3. Now, if we look at the combination, they are not all in series nor in parallel. حتى C1 with C3, they are neither in series nor in parallel. Because if I go from C1, I can go from C1 to C3, right? Across this line here. Let's go here so we can scratch. So we can go from here. We have a connecting wire to here, but we have branches. We have a branch that goes to C4, and we have a branch that goes to C2. And from the other side, actually, if we draw the battery, they are connected through the battery, so they are not connected directly. So they are neither in series nor in parallel. Same as C2 and C4, or C2 and C3. But we can see that C1 and C2 are connected here directly and connected here directly. Also, C3 and C4 are connected here, and they are connected as well from this side. So I can find the equivalent capacitor of C1 and C2, remove C1 and C2 from the circuit, put the equivalent capacitor, and see how the circuit would look like, and then I would use that to reduce the circuit even further. So let's do that. So let's say C1 and C2 are in series, are in parallel. So let C, I will call it 1, 2, be the equivalent. أنا طبعا مش كل مرة رح أكتب هالديتيلز، بس إنه for starter of C1 and C2. Now, C equivalent, C12 is equal to C1 plus C2. So it's equal to 0.25 plus 0.4. So that's equal to 0.65 farad. Now, also C3 and C4 are in parallel. So directly هسميها C34 equal to C3 plus C4, which is equal to 0.85 farad. Okay. Now كيف صار السيركت؟ Let me draw the circuit again. So محل ال C1 و C2 صار في عندي كاباستر واحد هو C12. ومحل ال 34 صار في عندي C34. صار في هاي الكونكشن بعدها بيناتهم. So I have now the connections. So I have the connection from here to here, and I have the connection that goes to the battery. So this is called C12, and this one here is called C34. Now, C12 and C34 are in series. So I can say that C12 and C34 are in series. So let's call their equivalent capacitor C. So 1 over C, let's make it an equation. 1 over C is equal to 1 over C12 plus 1 over C34. So that's equal to 1 over 0.65 plus 1 over 0.8. I think we have to take the common denominator, or we can just put them on the calculator and find C. So C is equal to, let's do that on the calculator. So I have, first I have to find 1 over C, this term. So I'm going to put a bracket, 1 over 0.65 plus 1 over 0.85, and then that is 2.7. So that if you want, this is equal to 2.7 5. Then I have to find the inverse of that. So power minus 1, that's 0.37 farad. 0.37 farad. الايكويفالنت تبع السيريز بده يكون اصغر من كل واحد منهم، يعني اصغر من 0.65. that's what we got. الايكويفالنت تبع البارallel هون عندي 0.25 و 0.4 بده يكون اكبر منهم 0.65. make sense. وهون نفس الشيء. so this is the series. طب هلا كيف صار السيركت؟ so I will can now remove one of the capacitors والسيركت صار just one capacitor, which I call it C, or you can call it C equivalent, whatever you want, and it is in, if you want, in the middle. Now let's put the battery. So this is C. So now let's put the battery. They say that we're connecting this to a 6-volt battery. So and اوكي. So الباتري نعمل وحده طويله وحده قصيره. So this is our battery. The battery is characterized by its EMF. So the battery, when they say 6 volt, that's the EMF of the battery. So we want to find the charge on each of the capacitors. So شو بعمل أنا؟ بلش combination of them, and I move backward. When they are in series, they carry the same charge, but the voltage is divided. When they are in parallel, they have, but the charge is what kind of add up. Okay, so let's say the delta V on the capacitor, the equivalent capacitor. Oops. Delta V on the capacitor C is equal to the EMF of the battery, because that's what it's connected for. So it's equal to 6 volt. So I can find the charge on the equivalent capacitor. So the charge on the equivalent capacitor is equal to C equivalent times the EMF, which is equal to 6 times 0.37. times 6, 2.2 coulombs. So that's the charge here. So that's the charge on this capacitor. So this is Q. Let's write it. So when we say Q, يعني ميلي في عليها plus Q وميلي عليها شو minus Q. طب now C1 and C2, sorry, C12 and C34 were in series. So they have the same charge as their equivalent. So this has to be Q as well. And this has to be Q as well. So now I can write, I can call it Q12, Q12 equal to Q34 equal to Q equal to 2.22 coulombs. Now, the voltage difference delta V12 is equal to Q12 over C12. So I can find the voltage difference. And I'm not going to put the absolute value anymore, but I'm always talking about the absolute value of the voltage difference. So this is equal to, we have 2.22 divided by 0.65 divided by 0.65. So that's 3.415. 0.4, sorry, 3.4. 3.415 volts. I can find the voltage on 3, 4. I can find it either two ways. I can say that the EMF or VPN is equal to delta V12 plus delta V 3, 4. So this gives me that delta V 3, 4 is equal to 6 minus 3.14. So that gives me 2.85, 585 volt. Okay, or I can say that دلتا مثل ما عملت ورا دلتا V34 is equal to Q34 over C34. It should give me the same answer. So now I have the voltage on this intermediate equivalent capacitors. أنا بدي the charge on the original capacitor 2 and 3, 3 and C4. So what I'm going to say now, C1 and C2 were in parallel, so they have the same voltage as their equivalent. So delta V one is equal to delta V2 equal to delta V12, which is equal to 3.415 volt. So I can find Q1, charge on 1, is equal to delta V1 ضرب C1. So it's equal to 3.415 ضرب قديش سي قلنا C1 هي 0.25, so that's 0.854 coulombs. ال Q2 كمان في يجيبها بطريقتين، يا اما بقول ال Q2 is equal to Q12 minus Q1, or I can say that the same as I did before, Q2 is equal to delta V2 ضرب C2. I can do the same for the 3 and 4. So for 3 and 4, I have delta V3 is equal to delta V4 equal to delta V34, which is equal to 2.585, and then Q3 is equal to delta V3 delta C3. I will leave the numbers out and you know what to do here. Or we apply that for 4. Oops. Okay, let's find another problem that we can solve for this combination of capacitors. So this is problem 94 from the book. So find the equivalent capacitance of the 4 identical capacitors shown in the figure, measured between A and B. If C is 10 microfarad, if 50 volt battery is connected across A, what is the charge on each capacitor? Now, مع انهم they are equal capacitors, sorry, but let's label them because they are connected differently, so they are different from each other. I'm going to start from here, so I'm going to label this one يعني C1 إذا بدنا أو capacitor 1. هيدا هون I'm going to label it 2. So see, labeling is very, very, very important because it tells me what I'm talking about. So ما بدنا نخبص بدون ما نكون عارفين عن شو عم نحكي. هيدا 2. هيدا هون 3 وهيدا هون 4. طيب. I'm looking between A and B, and you can imagine that between A and B there is a battery. Now if you look at 4 and 3, they are connected directly to each other, but there is a branch. From the other side, they are not connected because there are the other capacitors. So they are neither in series nor in parallel. نفس الشيء 3 و 2. They are connected directly from here, but there is a branch going to C1. From the other side, there is C4 between them, or the battery if I go to the battery. 1 and 2 are connected directly from here with a branch. From the other side, they are connected also with a branch. So 1 and 2 are in parallel. So I can start with those. So C1 and C2 are in parallel. يعني I can call C12 as their equivalent. So it is equal to C1 plus C2. And they are in parallel, they add up. So it's C plus C. So it is equal to 2C. Let's keep it in terms of C. Let's solve everything in terms of C for now. Okay. Now, كيف صار السيركت? Let's copy our capacitors from here. I'll copy this. Rearrange them. Okay. صاير عندي هيدي السي 3 خليها محلها. So هيدي هون السي 3. Let me remove this. Okay, here we have a connecting wire. Then we have these points A and B here, where I would connect the battery later on. Now this is C12 صارت هون محل ال1 ومحل ال2. معلش يسمحوني رح اخلي هاي الشحطه بيناتهم كرمال ما عادش اقعد اقصر الشرايط وطولهم وما بعرف شو. And C4 is here. Okay, so let's move those. So I'll copy. So هيدي 4 وهيدي هون 3 you know خليني label ال1 2. So هيدي ال1 2 مش 12 1 2. Okay, so now if we look at it صار بين 3 وال 1 2 branch راح البرانش بيناتهم صاروا in series. So C 3 and C 1 2 are in series. So صار عندي let's call the equivalent 3 1 2. So 1 over C 312 is equal to 1 over C3 plus 1 over C12. So this is equal to 1 over C plus 1 over 2C. So the common denominator is 2C, right? So I have 3 over 2C. So C312, I reverse this, it's equal to 2C over 3. يعني تلتين C. It has to be less than C لأنه C3 is C. So it's less than 1. So it's 2 over 3C. Now, كيف صار السيركت؟ So هيدا راح هون ما عادش عندي اياه. هلا بحطه فوق وبحطه تحت it doesn't matter. يعني هيدي هون في خليه هون في يحطه هون في يحطه تحت it doesn't matter because as long as they are connected الاورينتيشن والهاو هاو سيركتس صح؟ الشريط فيكم طويل قصير it doesn't matter. So let's label it though. So this is the C312. إذا نجي نطلع على 312 وال4 they are connected from the top side but there is a branch going to the battery to point A. They are connected from the bottom side but there is a branch going to the battery at point B. So they are in parallel. So C4 and C312 are in parallel. So C equivalent is equal to C4 plus C312. So it's equal to 2C, sorry, not 2C, it's C plus 2 over C over 3. So it's equal to 5C over 3. Now I connect it to the battery and I want to find the voltage across each. Again, I'm going to keep solving in terms of V. So let's call the voltage across the battery V and solve in terms of C and V. So we have the battery here. Let's call it V, or you can call it E. Let's call it the EMF. أحلى. الكيرل دي بس مشكلة الكيرل دي بدنا نقعد نلاقيها هون. Okay. So this is our battery. So we're connecting it to the battery. There it is. Okay. So now I can find the voltage on the equivalent capacitor first. طبعا ما رسمت انا مع equivalent capacitor but it's the same. بس خلاص راحوا ال4 وال3 to 1 صارت مع equivalent capacitor. So delta V is equal to, let me keep this in my copy thing so I can paste it whenever I want, is equal to E, the electromotive force, equal to the 50 volt. So I can find Q on the equivalent capacitor is equal to delta V times C. لا ما فيناش نسميها C لأنه C عندنا C هون. So let's call this C equivalent. Okay, لأنه في عندي C اللي هي ال 1 for each one of them. So C equivalent equal to E times 5 over 3C. So 5 EC over 3. So that's the total charge on the equivalent capacitor. Now, C3, 1, 2 and C4 are in series, are in parallel. So delta V four is equal to delta V 312 is equal actually to E. So I can find the Q4. So Q4 is equal to C4 times E. So it's equal to CE. That's it. Now I can find the charge on the capacitor 312. So Q312 is equal to, I can say that it is equal to Q, the total charge, or minus Q4. So it is equal to 5/3 minus 1 into CE. Well, 5/3 minus 1 is 2/3, right? We go back to the 1 over there. So it's 2 CE over 3. So that's the charge on Q312. So أنا ما بدي ال Q312, but I will have to go back. So now I can say that Q3 and Q12 are in series. So Q3 is equal to Q312 is equal to Q12. It's equal to that value that we wrote here, 2 CE over 3. Okay, so I found Q3 as well. Now I want to split 1 and 2. 1 and 2 are in parallel, so I need to know the voltage. So I have to know the voltage on 1, 2. So delta V12 is equal to Q12 over C12. So it's equal to 2/3 CE over 2C. So it's equal to E over 3. Oops. Let's copy E again. E over 3. طبعا بدها تطلع in terms of E لأنها voltage ما فيها تكون بقى تعتمد على ال C. So بدها تكون بس فيها E. So E over 3. Now I can find Q1 and Q2. First, it's the same voltage. So delta V1 is equal to delta V2 is equal to delta V12, which is equal to E over 3. So I can find Q1. هلا لانه نفس التشارج رح يكونوا equal, so Q1 is equal to Q, نفس الكاباسيتنس ونفس الفولتج, so Q1 is equal to Q2, so رح تطلع equal to E times C. Sorry, E times C over 3 لانه الفولتج هو E over 3. Any questions? طيب, I'm gonna stop here today. I will